Wow, what a difficult question. 5 lines of writing. The figures are embedded in the sentences. This will take a lot of time to unpack. If you've tried this question in other sources, the solution actually takes you through all of the numbers, but we don't need to do that. We can use a really nice shortcut because check out the answers. First thing to recognize is that the solution does not have numbers. There are no numbers here. So that's an important clue. Maybe we can solve this question with logic only. Okay, we don't have to perform calculations. Let's review what those variances are all about. Then we will make quick work of this question. So if we are looking, everybody, pardon my artwork, mix variance first. We are looking at the ratio of the inputs. And we need to compare the standard mix to the actual mix. And because there are no calculations, maybe we can just do this logically. So let's do mix variance first, then we'll come back and do yield. Let's come back to the question. And we have to find the inputs. We have to find which input is the cheap, which is the expensive. Then we have to find the actual. So we find the standard first, the actual second. And as we read the story, we see in order to make 19 liters of X, it takes 8 of A, 12 of B. So there's a bit of a normal loss there, but doesn't concern me at this point. We've identified 2 inputs, A and B, 8 of A, 12 of B. That is the ratio, 8 to 12, okay, or 3 to 4. Now, if we read the next sentence, we can identify which is the cheap, which is the expensive input. And chemical A costs 20 per liter. Chemical B costs 25. So check that out, everybody. That's the cheaper of the two. That's the expensive. Okay, let's come back down to this little table that we made. So we have standard A, B. Okay, that was 8 to 12. That's the cheap. That's the expensive. Now, let's dig around in the question for the actual inputs. How much material did we actually use in production? Okay. Can we find that? Sure we can. During September, actual results showed that we got 1,850 of output, but I don't need that yet, using a total input of 900A, 1100B. Let's just put those numbers side by side. Now if we look at actual, product A, product B, 900 and 1100. Oh, look at that. If we drop the zeros, if we drop the 100s, now we see 9 versus 11. So using logic, we can see that the company used a greater percentage of product A, of input A, and a lower percentage of product B. A is the cheaper stuff, okay? So they used more of the cheap, less of the expensive. Therefore, the mix variance, everybody, is favorable. Let's now move on to the yield. And now we need to look at the actual output of finished goods. And if we can draw our process again, the yield variance is looking at the inputs versus the output. Let's find out how much goes into one unit and how much we get out. Then we'll compare that to the actual. Okay, so if we come back to our question here, to produce 19 units, we have to put in 8 plus 12. Guys, that is 20. So 20 goes in, 19 comes out. How much did we actually get, everybody? We got 18. We got 18,500. Look at that. We got 18,500 out. How much did we put in? We put in 900 plus 1,100. Guys, that is 2,000. So we put in 2,000. So the yield variance is looking at in versus out. Guys, the standard says we should put in 20 liters. We get 19. The actual results show that we put in 2,000 and we got out 18,500. Okay, now you see what's going on here. Put a decimal place there, put a decimal place there, and it's easy to compare to the standard. So we put in 2,000 units of input, which should yield 19. Didn't yield 19, it yielded 18.5. So we got fewer units from our inputs. Everybody, yield variance is adverse. Okay, so which combination from the solution works for us? The mix was favorable, yield was adverse. The answer is D. Guys, we just solved quite a difficult question, but if you stay cool, if you step back and look at the big picture, very often when it's a difficult question, there is an easy shortcut. And here we saw that. We did not need to do the math as the model answer showed us. Instead, we used logic. Here we have another mix variance question. This time it's theoretical. It's just as challenging. What are they asking us? The following statements have been made about the materials mix variance. Now, before I start evaluating these statements, let me put the formula down. And if you'd like more information on this formula, how it works, I've got other videos on this. Check the link below for a deeper dive into how to calculate mix and yield variances. But for now, let's do this objective test question. So I'm going to throw down the formula. Actual quantity, actual price. That's the first variable I need. That's just the actual spend on materials. Then I'll do actual quantity, actual mix, standard price. Then I'll go actual quantity, standard mix, standard price. And then I'll go standard quantity, standard price. This is really the flexed budget. This is the actual results over here. How much should it cost when we produce our units? How much did it cost? We're always going like this, from right to left. If you want more information on that, check out my other videos. Now, when we do this, we get 4 variables. The price is always here, even when we're doing the basic variances. Then the new things, mix and yield. We're always moving from right to left. And let's look at the first statement now. The mix variance can be calculated by taking the difference between the actual quantity in the standard mix and the actual quantity in the actual mix. Well, look at that. Actual quantity, actual mix, actual quantity, standard mix. So yes, the mix variance looks at those two and multiplying it by actual cost. Actual cost is over here. Standard cost is here. Oh, so look at this. The statement is incorrect. It should be SQ. 1 is wrong. Now, the mix variance is about the ratio of the inputs. Did we follow the recipe card, did we follow the percentage of inputs? That's the mix. The yield variance is then about the total input to the output. Did the inputs yield more or fewer units than expected? The mix variance arises because there is a difference between what the input should have been for the out. Oh, as soon as we see the word output, it is wrong. Mix variance does not look at the output. The mix variance only looks at the ratio of the inputs. So neither statement is correct.